Hi, this is Ruben Chavez from Ceratec and welcome to our Tips and Tricks tutorial series. Thank you for watching this video on analyzing heat flow in a material. Please remember to like, comment, and subscribe for more helpful tutorials. If you have any suggestions or specific requests for videos you'd like us to create, please leave them in the comments below. Additionally, if you have any questions about anything covered in this video, please be sure to ask your questions in the comments below. If you'd like to see other tutorials like this, please check out our other videos here on our YouTube channel. We also offer our online customer enablement series held on the first and third Thursday of each month. This is a free 30-minute live video tutorial series where our software experts will share their techniques, tips, and knowledge that will help you sharpen your skills. To sign up for this series, please contact us at info@ceratec.com. Alright, so let's get into the content of this video. So in this video we have our mesh geometry, and for this geometry we're going to think of this block as a computer chip, and this is going to be the surface that it's laying on. For a computer chip, we know that it radiates energy and it emits heat, so we're going to see how this heat flows through this surface. So the first thing we're going to do is click 2D collectors and 3D collectors to hide the mesh. We don't really need the mesh. We're going to go to load types, we're going to go to thermal loads, and we're going to rename our load to chip heat flow. We're going to select our object, which we want it to be the top right here. And for our heat load, we're going to put 5 watts, enter, and we're going to click OK. Alright, so once we've set our heat load to 5 watts, we're going to want to create a thermal constraint on this edge and set our temperature to 25 degrees Celsius. So to do that, we're going to go to our constraint types. We're going to go to temperature. We want to change our filter right here to polygon edge. We're going to want to click our edge to be this one. We're going to want to set our temperature to 25 degrees Celsius, enter. And we're going to want to change it to edge temperature 25. Just click OK. Once we set our temperature constraint at the edge, we want to simulate a thermal coupling. And a thermal coupling just simulates the flow between two objects. So in order to do that, we're going to go to simulation object type. We're going to go to thermal coupling. We're going to change the name to chip thermal coupling. Once that's done, for our object, we want to select the bottom of this. So in order to do that, we're going to go to our polygon geometry. We're going to expand that. We're going to check this box off. We're going to click the bottom of this for our primary region. We can check that back in. For our secondary region, we're going to want to select the top of this. And then we're going to scroll down. For our magnitude type, we want our heat transfer coefficient. And for us, in this case, our value is 40,000. We're going to click OK, and as you can see, it's now ready to go. Once that's done, we want to create a convection to the environment constraint, and we do this in order to simulate the heat flow throughout the surface at a constant temperature. In order to do this, we go to constraint type, convection to the environment. We want to change the name to chip convention. From there, we want to select our object. We want to select each face. There should be 5 in total. And then we'll go back to our trimetric view. We'll scroll down to our magnitude top, our type. We want the convection coefficient. We enter this value at 24. For our temperature, we want to specify. And we click 30 degrees Celsius. Enter, and we click apply. So now for this next one, we want to go to our surface convention. We're going to do the same thing, except for this time, we're going to click this surface. We're going to go to our convection coefficient. We want to change our units to microwatts. We're going to click 19, enter. We're going to go to our temperature, specify, and click 25 degrees Celsius. We're going to click OK. Okay, so now we're ready to solve. So we go over here and we scroll down and we go to our solution and we'll right click. We'll hit edit. We'll shrink this down a little bit. And so here we're going to go to our run directory. We're going to change it from current simulation to solution name. We're going to hit OK. And then we'll go right back here. We'll right click. We'll scroll down to solve. And this might take a while. Just hit OK. So we'll be back. So once the solving is done, we can go to the post-processing navigator and load up the solutions, and this is what we get. So this solution looks correct because you see that the flow is around the chip and the load is not very large, so we don't expect it to go very far. And as we can see, Our edge temperature is the same and it still correlates to 25 degrees Celsius, so this solution looks good. That's going to do it for us today on analyzing heat flow in a material. Thanks for watching our tips and tricks tutorial series. This is Ruben Chaitis, engineer and intern at Ceratec. Please don't forget to like, comment, and subscribe, and also don't forget to ask any questions in the comments below. Also, don't forget to check out our other support videos here on YouTube and tune into our customer enablement series every first and third Thursday of the month. Thank you.
Thanks for checking out our channel. If you like what you saw, make sure to like and subscribe down below so you don't miss out on any new videos. Follow us on LinkedIn, Facebook, and Twitter for the latest engineering news and information. And to see all of our upcoming events, please visit our website at ceratec.com/events.